So we're looking at linear systems of equations. Linear systems. We did this last time as well. What's the difference between a linear equation and a system? Very simple. You just have two equations in a linear system. And usually, not all the time, okay? Usually, if you have two linear lines, they are going to intersect, okay? So what that looks like is something like this. If you have a line here, then another line may be something like this. They're going to intersect. There's an exception to this. The only exception is that if they are parallel. If they're parallel, that means they have the same slope but a different y-intercept. This is the only instance when they will never meet, okay, or never intersect. This system, let's say this is 3x plus 4, and let's say this is 3x minus 4. If this was your system, there would be no solution to this system because, as you can see, they never meet. But every other situation, doesn't matter, different slopes, same slopes, doesn't matter if they're perpendicular. What's the perpendicular slope of 3?
One over -3.
Yeah, 1 over -3 or -1 over 3. So even if they're perpendicular, they are gonna intersect, okay? The only exception to that rule is if they are parallel. That's in 2D. I'm just going to tell this to you, but this is not really we're not going to do questions like these for a long, long time if we ever do it. That was in 2D. In 3D, though, things are a little bit different. This is just for you to understand. 3D, we have 3 different axes, right? Like something like that. Let me draw that a little bit better because we don't need the negative quadrants. You have something like this. This is your x-axis, this is your y-axis, or let's call this a z-axis, this is your y-axis. So what happens in 3D is that even if they have different slopes, doesn't mean they have to meet. Look at this. Let's say you have a line going from x to y coordinate here, this axis, okay? There's a line going here, but then on the other side, you have a line coming up this way, like that, okay? What that means is that these two lines, even though they have different slopes, they are never gonna meet, okay? There's a term for these. This is called skew lines, lines that are skewed. This only applies through 3D. But for us, for grade 10, you're gonna stick to a 2D model. Last time we did substitution. Today we're gonna look at something else. This is called elimination. Why is this useful? It's useful if you don't want to deal with fractions. Here, let me show you what I mean by that. So this is a system, right? So if you're using substitution, you want to make y is equals to something and then sub that back in here as y. You could do that for x as well. It doesn't matter which one you sub in, you're going to get the same answer. But when it comes to elimination, the goal is to make sure at least one of the coefficients, either x or y, right? Not both, either x or y. We need these coefficients, either these two or these two, to be the same. And it's desirable to do this, to use elimination if you don't want to deal with, like annoying fractions like 42 over 7. Oh, that's 6, so that's whatever. But you can get something like 19 over 29 or something, which is very annoying to deal with. So in this case, what we're going to do is we're going to make sure one of the coefficients is the same. For that, we're going to need to look into LCDs. Okay, it's the same idea as LCD. Forget the prime numbers. Let's look at 12 and 8. What's the LCD between 12 and 8?
2.
So, like what I mean is LCD like this, right? If you have these two, what's the LCD between 12 and 8? It's not 2, because 2 doesn't go,
24.
it's 24, yeah. So what you're thinking of is probably the greatest common factor. Even that wouldn't be 2, that would be a 4, okay? What's the difference between LCD and GCF? GCF is the biggest number that goes into both of them, okay? GCF is the biggest number that goes into the numbers that you're interested in. Whereas LCD is the smallest number that both of those guys go into. It's the smallest number that the numbers you're interested with goes into, okay? The other way around. GCF goes into these guys, LCD goes into whatever LCD is. So anyways, the LCD between 12 and 8 is 24. What do we do with that information? We need to multiply 12 such that we get a 24. So that means we need to multiply this by a 2, because 2 times 12 is 24. Next, we need to multiply 8 by something to get a 24. How many times does 8 go into 24?
3 times.
3 times. So we need to multiply this by 3. So what does this give us? It gives us 14x minus 24y is equals to 84. Okay, so when you multiply the coefficient, you need to multiply every single term in there by the 2. So the first equation changes into this. Similarly, the second equation changes into 3 times 17 is 51x. 3 times 8 is 24y. And 3 times -2 is -6, like that. Now what do we do? So look at the coefficients that are the same. Here we have 24, 24, right? We need these two to have different signs, which we already do to begin with. But let's say this was a plus 24. If they have the same signs, you will subtract them. If that was a plus, you would subtract equation 2 from equation 1, the bottom from the top. If they have different signs, then you want to add them up like this, okay? And we're going to add one term at a time. So the first term would be 51 plus 14, that's 65x. And then you get 24, -24 plus 24, that's a 0. This thing cancels out. And then you have 84 minus 6, that's a 78. That means x is equals to 78 over 65, okay? And then plug this back into any of the 4 equations you have. So I'm going to plug it into the first one. 7 times 78 over 65 minus 12y is equals to 42 to solve for what y is, okay? And we can do this on a calculator. You don't have to find the GCF of 65 or anything. So to do this, it's going to be 14 minus 7 times 78 divided by 65 divided by -12. And I get -14 over 5 as my y value. -14 over 5. And there you go. That's the answer to this system of equations, okay?
Mhm.
Fractions, decimals, doesn't matter, whatever you're more comfortable with. So this saves you a lot of time, and because you're not dealing with pesky fractions. And B, whenever you're dealing with weird fractions, there's a higher chance you make a mistake, especially when doing LCD or not multiplying with the right guy. Let's try another one. Alrighty, so this one, again, is a word problem. You're going to have to come up with 2 equations. It's very important to identify what x and y is. What do you think x is in this case? X is always the thing that they're asking you, okay? So how far
Mhm.
did the submarine, yada yada, that's our x, easy. So that means x is underwater, y is on the surface. Cool.
Mhm.
So that's how a submarine operates. It's not always gonna be underwater. It's gonna travel like here, right? Like here, like a boat, and then it can dive in. Sometimes it's necessary to come back up to the surface, especially if the visibility is poor or in like murky waters and whatnot, right? And also to get some fresh air into the hull of the system. There are some submarines that can go on for months at a time underwater. How are they powered, do you think? Name me an energy source that could power stuff for months at a time, or maybe even years. Was it solar energy?
No.
No, right? Yes, this can power things for months, but we're talking about a submarine. Very little solar energy is going to get to the panels down there. Nope. What about wind?
No.
No, there's no way wind. You're not going to get wind down there. It's a renewable source. What other renewable sources do we have of energy? Solar and wind are the main two types, right?
Mm-hmm.
Is it coal? Someone's pumping coal in a nuclear. It's nuclear. Okay, so you have some nuclear powered submarines that can like run them for months at a time, even like massive cruise ships that run on nuclear power. Anyway, so X is what they're asking us. X is the distance. I can remember how far they're telling this. They're asking you for the distance. So X is the distance that it travels underwater. Y is this distance that it travels on the surface. There's gonna be two equations here. One of them is this 200. How do we use this in our equation? That's the total distance traveled.
X plus Y.
Yeah, X plus Y is 200. Now this one is a little bit weird. 12 hours. You see that 12 hours?
Mm-hmm.
Now the next equation is going to be time. It's going to be something plus something equals 12. Remember, distance is time times speed. So what would be our first, actually we're looking for time. So that means time is going to be distance over speed because it's 12 hours. Again, remember the units have to match up. So if you have hours here, you're going to need hours here and hours here. If you have kilometers here, all three units have to match up. So what's the time it took for the surface for this? Remember, time is distance over the speed. So the distance it traveled on the surface is y, right? What's our speed on the surface? It is
20.
20. Similarly, what's our distance underwater?
X.
Yeah, it'll be x over 10.
Mm-hmm.
Now we have a system of equations. I'm just going to show you this both ways. How to do this using elimination, how to do this using substitution. I'm going to need some space. So if you're using substitution, you're going to have to sub one in terms of the other. So this becomes either you can write this in terms of y or you can write this in terms of x. I'm going to write this in terms of x because x is the thing that we're going to need to solve for. So x becomes 200 minus y. So this equation, you want to plug this as x in there. So that's going to become 200 minus y divided by 10 plus y over 20 is equals to 12, right?
Mm-hmm.
How do we solve this for y? It's a linear equation. It has fractions and whatnot. Whenever you have fractions, try to take the LCD. What's the LCD between 10 and 20?
20.
20, right? So don't touch the y over 20 term, but we need this to become a 20. So we're going to multiply this with a 2 on the bottom. And whenever you multiply it on the bottom, you have to multiply it on the top like that. So this becomes 400 minus 2y over 20 plus y over 20 is equals to 12. Yeah? Now we
Mm-hmm.
can combine them. So this becomes, because they have the same denominators, it's going to become 400 minus 2y plus y, which is 400 minus y is equals to 12. Multiply both sides by 12. You get 400 minus y is equals to 2400. Yeah, like that.
Mm-hmm.
So this something went wrong here because this is gonna give me y is equals to 2000. 12. Negative y plus y is negative y. 12 times 200 is 2400. This gives here 400 minus 2400 will give me negative 2000. But we know that distance cannot be negative, right? So let's see if we did this right. X plus y is 200. That makes sense. Distance over speed. X over 10 plus y over 20 is 12. That makes sense as well. So these two are good. And then what did we do? We found, we subbed this in. X is 200 minus y over 10. That's good. 2 times 10, 20. 2 times 200, 400 minus 2y plus y. 400 minus y is 12. 12. Oh, yeah, I got it. It's not supposed to be 200. It was just 20. Like that. So 12 times 20 is 240, not 2400. And therefore y is going to be 400 minus 240. That's going to be 160. See that?
Mm-hmm.
Yeah, I don't know where I got the extra zero here from. But sometimes you see the answer is going to tell you you're wrong because distance cannot be negative. Neither can time, neither can speed. Okay? Those things are never going to be negative. Length, things like those, height, weight, you can always double check where something may have gone wrong. Anyways, we're going to plug that as y in here to get x. X is going to be 200 minus 160. It's going to be 40. So that's how you do it using a substitution. Okay, sub one in, solve for one of them, and plug it back in. Now let's look at elimination. To do elimination, okay, you need them to have the same coefficients. What's the coefficient of x here?
1.
What's the coefficient of x in the second equation? 'It's tricky. Is it 10?
No.
What's the x being multiplied by to get x over 10?
1 over 10.
1 over 10. Okay, so the coefficient here is 1. The coefficient here is 1 over 10. Same thing with this. Coefficient here is y. The coefficient here is 1 over 20. So what we can do is leave the first equation as it is. The second equation, you can either multiply it by 10 to solve for x, or you can multiply it by 20. Look at this, if you multiply this by 20, you get 20x over 10, which is 2x. You get 20y over 20, which is a y. Then you get 20 times 12, which is 240, okay? So this completely gets rid of the fraction, and that's what I would suggest. Just multiply it by the biggest number in the equation that has a fraction. So now notice we have y's. They have the same coefficient of 1. They also have the same sign. If they have the same sign, do you add or subtract?
You subtract.
You subtract, right? Now x minus 2x becomes negative x. Y minus y becomes a 0, disappears. 200 minus 240 becomes negative 40, and x is going to become 40. And that's what the question is asking you. If you want to find y, you go back into that equation. Y is 200 minus x, or 200 minus 40. It's going to be 160. And there you go. The answer is 40 and 160. And that's what we got down here as well. Y was 160 and x was 40. So both of the methods are valid, okay?
Okay.
You don't want to be graphing this because this is going to look super weird. You're going on the y-axis to 240 and your slope is 2. So you're going to get your y-intercept and your slope is going to be 2, which could be anywhere because your scale goes up to 240. So you're not going to get the right answer with a graph for this question. It says determine the hourly work rate for each worker. What's our x and y? So again, it's going to be important, right? What's our x and y? The easiest thing to do is just set x as whatever they're asking you for. So they're asking us for the hourly rate. We can say the rate for the welder is x, okay, x dollars per hour. And you can say the rate for the apprentice is y dollars per hour. Cool?
Mm-hmm.
X and y. And this is kind of like a distance time thing, okay? Rate is just your speed. Rate is the same thing as your speed. So you're going to get two different equations. The first one is going to be for the money that you make, the total money. It's going to be something plus something is equals to 346.
Is it just x plus y?
No, because x here is a rate, yeah?
Mm-hmm.
The rate, the unit is going to be dollars per hour, okay? Dollars per hour is a rate. This here is simply in dollars, so it's not going to be x plus y. It's going to be this. We don't know what the rate is, but this guy worked for 3x. This is the total money earned by the guy, by the welder, over 3 hours, okay? 3 times his hourly rate. Also look at it this way, 3x, does the unit match up? We know the unit has to be in dollars. The unit of 3 is hours. The unit of your x is dollars per hour, right? Like that. See the hours cancel out?
Mm-hmm.
Then you're left with a dollar, so it's gonna be 3x. 3x plus what?
5y.
5y is equals to, turns out this is 346 is for 7 hours and 8 hours. 3x plus 5y should be 175. There you go. That's your first equation. The second equation, also the information they've given us is the exact same thing. It's again, total money equation. What's the second equation?
7x plus 8y.
Yeah, 7x plus 8y is equals to 346. And that's it. Once you have the equation, things becomes kind of simple. What's the LCD between 3 and 7?
It's 21.
21. So you need to multiply the top equation by 7, and you need to multiply the bottom equation by 3. So it's going to become 21x plus 35y is equals to, I'm not even going to try and do that in my head, 175 times 7. 1225 is your first equation. The second equation, multiply everything by 8. Sorry, not 8, by 3. 346 times 3 comes 1038. Now, the x's, they have the same sign, plus plus, they have the same coefficient of 21. Do we add or do we subtract?
Subtract.
Subtract them, x goes away. 35 minus 24 is 11, and 1225 minus 1038 is 187. Divide both sides by 11, you get y is 17. Okay? So the rate for the apprentice is $17 per hour. And you can plug this into any of the 4 equations. Look at the equation. This one is 1. This one is 2. This one is 3. This one is 4. You can plug that 17 as y into any of the equations. I'm going to plug it into the one that has the smallest numbers, which is this one. So you get 3x plus 5 times 17 is 175. Subtract 5 times 17 from both sides. 3x is 90. Therefore, x is $30 per hour. There you go. And that's how you'd do this question. Okay?
Mm-hmm.
And just check if everything adds up. 30 hours. You can quickly check if you've done this right? So if you plug it here, 30 times 3, that's his rate. The other guy's rate is 17 times 5, and that does add up to 175. So you can quickly check if you've done this right. And it makes sense because the welder should be earning more, and both the rates are positive. It doesn't necessarily have to be a whole number. Determine without graphing the point of intersection, it says. How do you find the POI between two lines?
You set the two equations equal to each other.
Yeah, you could do that, or you could, that's the same thing as solving a system of linear equations, okay? You can do that.
Mm-hmm.
That requires you to write the things in terms of y equals mx plus b, but you don't always have to do that. That works. So you can just solve this, because this is not in the slope-intercept form. I'm going to solve for y. So the LCD between 3 and 1 is 3. So the first equation remains untouched. The second equation, you need to multiply this by a 3 in order to get a 3y here. So this becomes 12x minus 3y equals 66. The y's, they have the same coefficient, different signs. Add or subtract?
Add.
So you get 13x is equals to 65. X is 5. Plug that back into any of the equations. 5 plus 3y is negative 1. 3y is negative 6. Y is negative 2. Therefore, the POI is x equals 5 and y equals negative 2. Now, sometimes what happens is you need to verify this, right? How do you verify it? I'm going to show this to you. I'm just going to do a little thing called check or checking or whatever. We're going to plug x and y in here, see if that adds up to negative 1. So x is 5 plus 3 times negative 2. That's 5 minus 6, that is negative 1. So it checks out. We're going to do the same thing here. 4 times 5 is our x, minus y is minus negative 2. So this becomes 20 plus 2. That is indeed 22. So the second equation also checks out. Okay, so when they ask you to verify it, just plug the answer back into the question, see if it makes sense. Okay, that's how to do the verification. Alrighty here. So there's two ladies, Lori and one guy, one girl. They walked 72.7 kilometers together. Lori walked 8.9 kilometer farther than Nicholas. Create a system to model this equation. So let's say Nicholas walked X kilometers, okay? We know Lori walks 8.9 kilometers more. What's Lori's distance in terms of X?
X plus 8.9.
Yeah, X plus 8.9. So we have X plus 8.9 is equals to 72.7. 2x is equals to 72.7 minus 8.9, 63.8, and x is going to be 63.8 divided by 2, 31.9. Plug this back in here to find your Lori's distance. 31.9 plus 8.9. That'll be 40.8. And that's how you do that question. Okay, super simple because you only have one variable to deal with. I'm trying to find a specific question, but doesn't look like it's here. Let's try doing this one. So there's two fruits here, mandarin and a tomato. And they've given us their vitamin C content and vitamin A content. And they're asking us for how many grams of oranges and tomatoes, right? What's our X and Y? Again, X and Y is always going to be whatever they ask you for.
How many grams?
Yeah. X and Y is going to be the grams. I'm just trying to find something. Okay, whatever, doesn't matter. Well, we'll do it in a little bit. So let's say X is the oranges and Y is the tomatoes. What is going to be our equation? This one is a little bit tricky.
So is there one equation for vitamin C and then another
Yeah,
for vitamin A?
maybe that would be better because this one, let's set that as our X and Y. So let's set this as our X, okay? And let's set that as our Y. What would be the first equation? Or you can do whatever you think is best. Okay, you don't have to. There's multiple ways to do this because you have 4 different things going on here. So you can either let A and C be X and Y, or you can let oranges and tomatoes be X and Y. What would be the equation for vitamin A? Look at this. Let's say oranges. Let's stay with our original plan, okay? X is this, tomatoes is oranges. So that's the grams. 1 times X, 1 gram of oranges plus 1 gram of tomatoes, yeah? That is equals to how many vitamin A's do we have? We had 13 from the first one and 42 from the next one. So that's 0.55. Okay, like that. The next equation will be what? X plus Y equals what? That'll be for vitamin C. Again, 1 gram of orange plus 1 gram of tomato has 0.13 plus 0.42 of vitamin C, right? I'll be 0.55 as well. Actually, I didn't, what was the vitamin C? This should have been 13 plus 26. That should have been 0.36. Like that. Cool? Now look at this. Now this is where you're gonna get the full marks because this is a very tricky question. Is this system solvable?
No.
Why not? Like if it gave you this question and it asked you, why is this not solvable? What's the answer? Needs to be something technical or whatever you think is the answer. It's because these two lines, yeah? What's their slope?
We don't know.
Yeah, you do know, because slope is just the coefficient in front of x. Right? If you were to rewrite it in this form, you're gonna see that the slope is what? -1, right? Are these lines ever gonna meet?
No.
No, what does that mean? That means the system has no solution. Okay, using this approach, the system has no solution. Make sense? So that means we need to use a different system because this as is right now doesn't help us. Think of another approach. I'm gonna do this. Let's say vitamin C. And again, what's the best approach is always whatever the question's asking you. I think they're asking you for this. Your oranges, right? How many grams of oranges and how many grams of tomatoes individually? I think that's what they're asking us. Will have this quantity. Think about it this way. There's 1 gram of orange, okay? This has 0.26 mg of vitamin C and 0.13 mg of vitamin A. Okay? How many grams would you need to have 13 mg of vitamin C? You'll just do 13 divided by 0.26. 13 divided by 0.26, which is 50 grams. You see that? How many grams would you need to have 20.7 mg of vitamin A? We know 1 gram has 0.13, so you just divide this. 20.7 divided by 0.13 is going to be 159 grams. And there you go. That's for oranges. And then you want to do the same thing for the other guy, tomatoes, right? The first tomato is going to be 13 over 0.26. No, 0.26, it's going to be 13. So 13 over 0.13, whatever that is, it's going to be 100, I think. And the next one is going to be 20.7 divided by the quantity in the tomatoes. it's gonna be 0.42, which is going to be whatever that is on a calculator. Okay? Here, let's do a question like this. Sometimes where it's very tricky to come up with an equation. Let's say a builder, okay, there's a builder. He builds 10 houses in 100 days. Okay, like that. Same builder, how long is it going to take him to make one house? How many days?
It'll take him 10 days.
It'll take him 10 days, right? What does you do?
Divided 100 by 10.
Now look at this. This is gonna sound weird. How many houses, okay? How many houses does he build in one day? He builds 1/10 of a house, okay? He builds 10% or 1/10 of a house in one day. That makes sense?
Mm-hmm.
You divide the other way around. You do, instead of doing 100 over 10, you do 10 over 100. Now check this out. There is builder A, okay? There's builder A. Let's say he finishes a job, he finishes one job, whatever it is, in 3 hours. Let's say there's builder B. He finishes one job, let's say something we can do LCD with 5 hours. So this is them doing it individually, okay? This is them doing it individually. This is gonna be a 4+ question, which is very similar to the one we did here. I think this is the approach. Sometimes this is better. How long will it take for them to build it together, to finish one job together? This will be a question. This would come up on like a math competition or something as well. How do you even approach a question like this? The approach is always going to be this. Bring it down to either 1 day, 1 hour, whatever the unit is, okay? If builder A finishes one job in 3 hours, what fraction of a job does he finish in 1 hour? If he finishes one job in 3 hours, in 1 hour, how much of it is he going to finish? He's going to finish a third of it. Does that make sense or no? Because this is the most important part here.
Mm-hmm.
In 1 hour, he's going to finish one third of the job. Whatever builder B, in 1 hour, what fraction of the job is he going to finish?
1/5.
1/5. Okay, there you go. Now look at this. Together, okay? Together, in 1 hour, how much work are they going to get done? The first guy finishes 1/3 by himself, yeah?
Mm-hmm.
The second guy finishes 1/5 by himself. So in 1 hour, you take the LCD, they finish 8 out of 15, okay? So in 1 hour, they finish 8 out of 15. Therefore, to do one job, okay, to do one job, what you do is you simply flip this over. It will take them 15 over 8 hours, and that's the final answer. A little under 2 hours. Simply flip it, or in other words, you do this. You do one job divided by the job per hour, and that'll give you 15 over 8. And that's the final answer for this question. Cool?
Mm-hmm.
So this is a very tricky question that you can see sometimes It's useful as well in real life, I guess. Let's try this one. Read this question. Tell me what an x and y is. They're gonna be the numerators, okay? So let's say the first fraction is x over 3. The second fraction is y over 4. Look at this. What's the first equation? The sum of the two fractions is equals to what?
17/12.
17 over 12. Now look at the second equation. It says if the numerators are switched, that means x becomes y becomes x. Their sum is 3 over 2. What's the second equation?
Y over 3 plus x over 4 equals 3 over 2.
Yeah, 3 over 2. So now you have a system of linear equations. How do you solve this? I think the easiest thing to do would be to multiply both equations by the LCD of 3 and 4. What's the LCD between 3 and 4?
12.
12. So we're going to multiply both equations by 12. That'll get rid of the fractions completely. Look at this. The first one's going to be 12 times x over 3, which is 4x. The next one will be 12 times y over 4, which will be 3y. And it'll be 12 times 17 over 12. What's 12 times 17 over 12? 12 times 17 over 12.
It's 17.
It's just 17, right? Like, there you go. That's your first equation. The next one, 12 times y over 3 is 12 over 3, 4y. 12 times x over 4 is 12 over 4, 3x. And 12 times 3 over 2 is 18. Yeah, like that. Now, does this help us? It does in the sense that you don't have to deal with fractions no more, okay? Next, I'm just going to rewrite this as 3x plus 4y. 3x plus 4y is equals to this. Now, we're going to do this once more. Multiply this by 3, multiply this by 4. The first equation becomes 12x plus 9y equals 51. The next equation becomes 12x plus 16y is equals to 72. There you go. No fractions, and all the numbers here you can work with. You're going to subtract them because 12x and 12x, they have the same signs. 9 minus 16 is negative 7y. 51 minus 72 is negative 21. That means y is 3. Okay? And you can plug this in any one of them as you want. I'm going to plug it in here. So 3x is equals to 18 minus 4 times 3, 12. 3x is 6, x is 2. There you go. We had some fractions in the beginning. We completely got rid of them. And you can, once you get rid of the fractions, you can kind of do the maths in your head. Okay? I'm gonna do the trickiest question of the day. It's not that tricky once you figure it out. There's a little thing that you need to do, but I think you can do it even without any tricks. So there's two people. There's Adam, there's Brian. Adam is 20 years younger than Brian. In 2 years, Brian will be twice as old as Adam. How old are they now? What's your x? There's no y here because you can write Adam's age in terms of Brian's. You can write one in terms of the other, so you don't really need a y. What do you think x is?
Their age.
Whose? Gonna let Brian, okay? Brian's age be x. If Brian's age is x, what's Adam's age? Remember, he's 20 years younger.
X minus 20.
Yeah, x minus 20. So this is your thingamajig now, okay? These are their ages right now. Now let's fast forward 2 years from now. 2 years into the future. What will Brian's age be?
X plus 2.
Yeah. What's gonna be Adam's?
X minus 18.
X minus 18. How are these two related in 2 years from now? We know that Brian, yeah, and Adam, whatever Adam's age is, Brian is gonna be twice as old, right? In 2 years?
Mm-hmm.
And this is the trick here. It's not really a trick, it's just following the question, but you need to come up with this equation. We know Brian's age is x plus 2 in 2 years is equals to 2. And we know Adam's age is x minus 18 in 2 years. You don't really need a bracket like for Brian. How do you solve this linear equation? Just use BEDMAS, yeah? If there's a bracket, open it. What do you get if you open that bracket?
2x minus 36.
36. Subtract 2x from both sides, you get minus x. Subtract 2 from both sides, you get minus 38. Therefore, Brian right now, remember, x is Brian's age right now. Right now, Brian is 38 right now, and Adam is 38 minus 20, so he's 18. Now let's see if this makes sense. 2 years from now, Brian is going to be 40. 2 years from now, Adam's going to be 20. Is he double the age? Yes, right?
Mm-hmm.
So there you go. That's how you do this question. It's not that difficult, but this right here is the most important thing. And he might not be twice his age. They might be like he is 3 less than double his age or something like that, 7/10 of his age. You can always put different things on it, but this right here, this is a crucial equation. And this bit here as well. You need to come up with their ages in the future because this information here in 2 years, that requires you to have the x in the future, x plus 2 basically. All right, let's call it a day there for today.
Okay, thank you.
See ya.